In this lesson, we'll discuss 4 web safety issues: handling files on a web browser, accepting cookies from websites, using a more secure version of HTTP called HTTP Secure or HTTPS, and keeping and deleting a web browser's history. Safe browsing issue number 1 is handling files. Some of you may be watching this video as part of a course that uses this textbook. If you are, you should know that we're about to examine some illustrations from Chapter 7 of this book. If you aren't using the book, then don't worry about it. Just follow along with the lesson. This diagram shows how Alice's computer interacts with files from the web. If you understand how a web browser interacts with files from the web, then you will stand a better chance of avoiding malware from the web. Let's examine this diagram beginning on the right side of the page. Web pages are a type of electronic document, and they are stored on remote computers called web servers. Your computer accesses web pages on web servers through the internet. The red line in this image represents the internet connection between Alice's computer and the web server. Now, you may remember that when computers communicate, they can only understand each other if they stick to a strict set of communications rules, and these rules are called a protocol. The web browser on Alice's computer and the web server are using a protocol called Hypertext Transfer Protocol, or HTTP. Web browsers and web servers almost always use HTTP to communicate with each other. The most common exception to this rule is that some web pages use an encrypted version of HTTP called Hypertext Transfer Protocol Secure, or HTTPS. We'll talk about HTTPS a little more later in this lesson. For now, I just want you to see that when you browse the web, your web browser and a web server somewhere are trading information back and forth using some version of HTTP. When your browser sends out a request for information, the web server will normally return some web page that you have asked for. The web page itself is coded in a programming language called Hypertext Markup Language, or HTML. A major component of the web browser, then, is the HTML interpreter, which allows the web browser to decode and display web pages that are written in HTML. In this image, notice that Alice's whole web browser is represented by a red box, and the HTML interpreter part of her browser is represented by a smaller black box within the web browser. The HTML interpreter is part of the web browser, but the web browser does more than just decode and display web pages written in HTML. When the HTML interpreter reads through the lines of code for the web page, it will occasionally find non-HTML files embedded into the HTML code. For example, it might find a video file or a PDF embedded into the web page. Videos, PDFs, and other embedded files aren't written in HTML code, so the HTML interpreter cannot display these files without some help. Alice's web browser has several plugins, that is, several helper applications that are programmed into the web browser itself to help it to interpret non-HTML files that are embedded into web pages. In this image, we see that Alice's web browser has 3 kinds of plugins. Executable plugins run programs embedded into web pages, programs written in coding languages like JavaScript. Document plugins allow Alice to view documents, such as PDF files, straight from her web browser. Viewer plugins allow Alice to view or listen to other image, audio, video, or graphics files from her web browser. Sometimes, Alice's web browser will encounter a file embedded in the HTML of a web page that it's not able to interpret with either its HTML interpreter or with any of the other plugins that it has available. When this happens, the web browser might ask a helper application located somewhere else on Alice's computer to open the file. Alternatively, Alice might choose to download a file from a web page. When she does this, the file is downloaded onto her computer, normally someplace on her hard drive, and she can open that file later, even if she is disconnected from the web server or from the internet altogether. So, as you can see, Alice's web browser encounters a number of different file types, and it can handle those file types in a number of different ways. As a user, Alice has some control over how her web browser handles files that are embedded into web pages. Let's imagine for a moment that Alice uses the Firefox web browser. If Alice opens the Options window in Firefox and selects the Applications tab, she can control what action her browser takes when it encounters any given type of file. For example, she can control whether the web browser will execute the file automatically or if it will ask for permission first. In this illustration, we see that Alice's web browser is set up to automatically open several file types with Adobe Acrobat. We can also see that Alice's browser is set up to open various audio-visual files automatically with a QuickTime plugin, which is also located in her browser. However, whenever her browser encounters a compressed folder, it will ask for permission to open it or to save the file. Alice doesn't want her browser to automatically open or to automatically save compressed files. She wants to process those files manually. This next illustration shows how Alice can change the way that her computer handles files. In Firefox, she clicks on the bar displaying the action for a given file type, and a menu drops down with several options. She can command the browser to always ask her how to handle a given file type, or she can command it to always save a given file type to a particular location, or she can command the browser to always open the file. Her browser is recommending that she always open Microsoft Word documents using Microsoft Word. But if Alice prefers a different word processing software, she can specify that a different program besides Word handle these files. Alice can adjust these settings for any file type that she might encounter in her browser. So, what should you do? Should your browser automatically open files embedded in web pages, or should it ask you for permission first? Now, obviously, the most convenient option is to allow the web browser to just automatically process files. If it's automatic, then you don't have to think about it. But because some files might contain malware, automatically executing all files is also the most insecure option. The best thing for security is to pick and choose manually which files your computer opens. You will have to strike a balance between security and convenience based on your own computing habits and your own needs. Do you encounter a lot of files from unknown sources? If so, you probably want to screen those files. But do you stick to relatively few, familiar, and trusted web pages? Then maybe for convenience sake, you could allow your browser to open files automatically. Now, you may not use Firefox, or maybe you do use Firefox, but our images may have become outdated because of a recent upgrade, which is very possible given the speed at which technology develops. But no matter which web browser you use, it should allow you to control how it handles files one way or another. So do some exploring and figure out how you can do that in your web browser. Safe browsing issue number 2 is cookies. Cookies are small files that websites leave on your web browser. Cookies allow websites to remember users' behaviors and preferences on a given website. They enable a lot of the features that web users like. For example, cookies are what allow a website to remember whether or not you're logged in with your user account. Cookies also allow shopping websites to remember what items have been placed in a user's shopping cart. Furthermore, cookies are simple text files, so they can't contain any code that would run a program, and therefore they cannot execute malware infections on your computer. So cookies are great for convenience, and they are malware-free. But cookies have a downside too. One particular kind of cookie, called a tracking cookie, can track user activity across the internet. Many users feel like tracking cookies are a violation of privacy. For example, if you shop for baseballs on baseballgear.com on Monday afternoon, you might notice that a new website starts showing you ads for baseball bats and gloves on Monday evening. These targeted ads imply that your behaviors are being observed and shared between websites and between different companies. This is made possible by tracking cookies. Tracking cookies are ultimately all about advertising. As you can imagine, advertisements are much more valuable if they're tailored towards your personal interests. The more targeted the ads are to you, the more effective the ad usually is. That's why advertisers advertise toys during children's shows and beer during football games. The people who are interested in children's TV shows are statistically more likely to be interested in toys, and the same people who are interested in football games are statistically more likely to be interested in beer. Tracking cookie companies pay websites to run software that writes tracking cookies onto your browser. These tracking cookies can collect information about you on any website that runs the software by the tracking cookie company. Over time, the tracking cookie company builds a profile on the user behavior associated with your web browser, and it can use that profile to direct targeted ads to your browser. It reads the cookie, it observes your browsing behavior, and it says to itself something like this: I see that you've been reading about baseballs and buying baseballs. I guess I should show you these baseball bat advertisements because it seems likely that you're the kind of person who'd be interested in buying a baseball bat. Another issue with cookies is that they can allow users to stay signed in to online accounts on their browsers. Now, on the face of it, there's no major issue here. Why would it matter if you stayed logged in on your own private computer? Well, it only becomes a problem if somebody is allowed to snoop through your computer. For example, you might leave your computer in a public place. Or, more likely, you might leave your computer out at home during a party or a gathering. Or if your boyfriend or girlfriend has access to your computer, then they might have automatic access to your accounts. In any of these situations, somebody else could use your active login information to access your online accounts. So although cookies are more convenient for you, keep in mind that they're also more convenient for people who snoop through your computer. And of course, if you're using a public computer, then make sure that it does not remember the password for your online accounts. You don't want people in public to log into your private accounts. One final security issue with cookies. If you are using an unsecure wireless connection, then eavesdroppers can intercept cookies sent to and from your computer. If the cookie in question happens to be an authentication cookie that's used for logging into an online account, then the eavesdropper can save this cookie and use the information on it to log into your account later. Safe browsing issue number 3 is HTTPS. Earlier, I mentioned that web browsers communicate with web servers using a protocol called Hypertext Transfer Protocol, or HTTP. Regular HTTP is a set of rules that governs the way that code is sent back and forth between web browsers and web servers. Regular HTTP sends code back and forth in clear text. That is, the code is easily readable for anybody who has access to it. So if somebody happens to be eavesdropping on your browsing session on an unsecured wireless network, they can easily read any information that is sent through HTTP. There is another protocol called Hypertext Transfer Protocol Secure, or HTTPS, that adds another step to the HTTP protocol. Instead of sending code back and forth in clear text, HTTPS adds a step of encryption. If you navigate to a web page using HTTPS, then the website encrypts all of the code that it sends to your web browser, and it gives your web browser a unique key for decrypting that code. Eavesdroppers will still be able to see your traffic on an unsecure wireless network, but if your browser and the website are communicating with HTTPS, then the traffic between them is unreadable for the eavesdropper. The eavesdropper will only intercept an encrypted mess of unreadable, garbled code. Many web pages use HTTPS for their login pages so that your login credentials are secure as they move across the internet. If you're going to submit sensitive information online, you should make sure that you're using web pages that use HTTPS. Most web browsers display the address bar differently for a web page that uses HTTP than it does for a web page that uses HTTPS. Here's what the difference looks like in Firefox. The page on top uses HTTP, and the page on bottom uses the more secure HTTPS. Notice the green padlock and security certificate on the HTTPS page. Here are the same two pages shown as they would display on Google Chrome. Again, HTTP is on top and HTTPS is on bottom. Notice once again the green security certificate and padlock icon on the HTTPS page. You should be aware that HTTPS helps to protect you from wireless eavesdropping, but HTTPS can't protect you from malicious websites. Not every website that uses HTTPS is necessarily safe. Bad guys can use HTTPS too. It's just that using HTTPS will protect you from wireless eavesdropping. You should still proceed with caution on websites that you do not recognize and trust, even if they use HTTPS. Safe browsing issue number 4 is browser history. As you probably know, your web browser normally keeps a complete record of which web pages you have navigated to. This history can be convenient. It helps you to remember things that you have read online, and it helps you to navigate to frequently accessed web pages more quickly. But like most convenient things, browsing histories trade security for convenience. Your browser won't differentiate between sensitive and non-sensitive information. It will keep a complete record of all of it. Anybody who cares to snoop through your browsing history will be able to see what you've been doing online, perhaps including where you do your banking, whose Facebook pages you have visited, or what kinds of medication you've been researching. Web browsers on public computers will normally default to recording your browsing history too. If you use a public computer, say one at a library, then practically anybody can see what you were doing after you leave the computer. There are 3 primary ways to control your browsing history. The first is to delete your history. Your browser should have a delete history function, and all of the most popular browsers will give you some control over what you delete. For example, Firefox will allow you to clear your history going back different amounts of time, an hour, a week, etc. And it will allow you to clear all of your history at once, or to just focus on one specific kind of information: cookies, browsing history, data typed into online forms, etc. The second way to control your browsing history is to limit what kinds of information your computer gives, receives, and remembers. For example, in Firefox, you can control whether the browser remembers your browsing and downloading history. You can also control whether the browser accepts cookies and how long it retains those cookies. The third way to control your browsing history is to use the private browsing setting in your web browser. The private browsing setting normally opens up a new private browser window. When you decide to close this window, it will automatically delete all of the history and cookies that you picked up during that browsing session. When you open a regular browsing window again, your browser will default back to whatever default settings you normally use. Okay, to review, we covered 4 web safety issues in this lesson: handling files, accepting cookies, HTTPS, and browsing histories.